Okay, I'm ready. So last day, woohoo! Yay! For the whole day, the topic is BIG-IP DNS or GTM, and we're going to kind of cover this in a couple different sections. The first part really is the kind of a little bit of a review of DNS. We're not going to make this into a DNS class, but we want to do a little bit of a review just so that everybody's on the same page, and then it makes sense how you would position BIG-IP into that picture, right? Where this product fits. So we'll do a little bit of a review and then specifically talk about how you would deploy BIG-IP DNS. No labs in the first section, just kind of a discussion. But then we go in and we talk a little bit of the history of BIG-IP DNS and GTM, and there we'll focus on some of the features that have been added recently. A lot of security things have been added in the last several releases, so this one's a little bit more on the security, and we'll do a lab, get it all set up and working, and do a few small things with the product in that lab, and specifically focusing on order of precedence. Do you remember the discussion we had the other day about packet comes in and there might be multiple virtuals that match the criteria of the packet, who wins, who's going to grab it, and it's most specific to least specific, the wildcard virtual server. Same idea here. DNS query may come in and you might have multiple things configured. Which one is going to grab that query and then answer it? Okay, so we'll talk about that order precedence and do a lab on it. And then finally, we're going to get to the history of the product, which is where it's always been all along, and that's global server load balancing. It's not an F5 term. It's a way using DNS to distribute traffic to multiple data centers, and other vendors out there do that also. But this is where the product kind of came from, the history. And we'll do this in 2 steps. This is one of those topics that you have to learn something about this before you can learn about this, but you have to learn something about this before you can learn about that. So it's one of those catch-22s that will ratchet up a little bit on one side and then we'll ratchet up on the other side and come back and do it kind of in 2 parts and 2 labs. So, good? Questions? First, maybe a question for you guys. How many people have worked on this product before? So a few. A little bit. Okay, good. How many people would consider themselves at some point they did a DNS admin job? Okay, so that's more than the typical group that will answer that that way. Normally, people, you don't have quite as many that have done DNS admin type of job, but that'll help you in understanding how this product works, I think. So, okay, so lesson 1, real quick DNS review. There are a couple ways that you can host DNS. One is with a provider where you're paying somebody to host your DNS infrastructure, right? There's advantages and not advantages, disadvantages, but pros and cons to that. You typically have smaller organizations using this because they don't want to pay a DNS admin, to do just this one job. But you also have less control. Right? You can't change things. It's up to them to change things. When changes happen, you have to go through that hosting provider. Often it's more expensive because you're paying them to do that. Other way, of course, is in-house, right? Where you're going to host it and you're going to have a person managing your DNS infrastructure. More flexible, right? Just the opposite of the previous one. More flexible, but you've got to pay somebody to do that. So many customers will do one or the other, but you also see some of them doing kind of a split DNS where you've got some stuff managed in-house and some stuff that you have the hosting provider control. Right? Maybe your external stuff, in-house you're doing all the internal DNS stuff for your company. Hosting provider does the external stuff, as an example. Especially if you want some high availability and you only have one data center, you have single points of failure in your network. A lot of times they'll have a hosting provider do their external DNS infrastructure. Good? Kind of makes sense? So now the questions. how does DNS work? And we'll do this kind of in an interactive way. I want to see where you guys are at. But just to kind of a review, get straight in your head, reviewing what DNS works, or how DNS works, because then we can better understand how you're going to put BIG-IP in there and have it do stuff for you. So what's the first thing that happens? Somebody types in www.domain.com. What's the first thing that's going to happen on their local cache, right? Local machine, right? So it's going to look in the local cache. If it doesn't find it there, then what happens?
I go to the cache of the service provider, caching DNS.
It goes and asks the local DNS, and at that local DNS, it may be cached, right? Okay. That local DNS is going to look it up to see if it's in its cache. If he doesn't have it, now what?
It goes to the root domain.
Root. Do that traversal of the root tree, right? So you go to the root servers, right? Those are all known IPs and distributed around the world. They then tell you where to go for .com, right? So then you go to .com. .com then tells you where to go for domain.com, right? Once you get to domain.com, this is the part that you may be hosting and owning and controlling, or somebody does for you. If that guy has the record, what's he going to hand back?
They send you a record.
A record, right? So an address record. So he'll hand back an A record, right? And when he hands that back, there's also a value included with that A record, or configured with that A record, that says how long it's supposed to be valid, right? What is that called?
TTL.
TTL, time to live, right? So that goes back to the local DNS, right? That local DNS is going to cache it for how long the TTL is, assuming they're living by the normal rules. If they don't, then we can't. And then once that gets to that guy, he of course has to hand it back to the client, right? So now the client ends up with it, and then finally, once we have all this resolved, now we're going to go establish a session with the actual application. Right? Good? Kind of make sense? So having that as a background, now we can kind of talk about where are we going to put BIG-IP, and what's the advantage that we can do for helping this. And there's some pieces that we'll need to make sure you understand we're going to do differently. But we still have to live within this, and for instance, if the hosting provider, in our case, doesn't live by the TTL and ups it, for example, say maybe we put a very short TTL in there and they increase it to 4 hours or a day, nothing we can do. Okay, so there are some limitations because of this infrastructure, right? We're still living within the confines of the DNS architecture and how that works, but we're going to try and do some fancy things. So when you deploy BIG-IP DNS, it's kind of one of two different ways that you'll hear. First, before we talk about that, what are some of the standard limitations of standard bind or standard DNS? One is it's not real true high availability, right? If we were to have handed back that A record and that site was down, port 80 maybe not working, client is still going to try and go there, right? And get some site not available. So not true high availability. Really only supports round-robin load balancing. You can't change over very easily. There's not an easy way to do that. It's more of a manual process. Can't really do anything with persistence, right? If you want this client to go here and then you want to keep sending them there, in the traditional bind or DNS, the round robin may direct them to another site, right? So no real ability to persist. Manual intervention we kind of already talked about. And then the normal DNS or bind infrastructure is fairly vulnerable to attack. Just the nature of how it works. You often get into some of these DDoS attacks on the DNS infrastructure itself. That's a real good area for us to try and position ourselves as we can help with that, and we'll talk about one of the ways that we help with that. So that's some of the stuff that we've added recently that really is one of the bigger advantages of using BIG-IP to potentially still have your bind servers behind, but having BIG-IP DNS in front and answer for some of these DOS attacks on the DNS protocol itself. Good? So you'll hear people talk about potentially two ways to deploy BIG-IP DNS in this architecture or this structure. One is in what you might hear referred to as delegation mode. That's the old way to do it. There's still people doing it, but that's the old way to do it. A lot of customers only wanted to do this because they didn't, you came in and tried to pitch them on, we can help you send traffic across your data centers. Okay, good. I'd like to do that. I'd like to make them more highly available, and I'd like to kind of fail over periodically to this data center or that data center. We can help you with that. We're going to use the DNS infrastructure to do that. Oh, I don't want you touching my DNS servers. Okay, well, that's the way that we implement this. And what if you really want that www.company.com site to be highly available? We can help with that. Okay, well, maybe just that DNS name, nothing else. I don't want you messing with anything else in my DNS infrastructure. This kind of accommodated that, right? You would tell them that, okay, well, we can do it that way, and then we're only helping or we're only handing out answers to that one name, right? And nothing else. That's why people wanted to do delegated mode or delegation mode. How this worked was very similar. Again, the client asked for the name, right? Local DNS doesn't have it in its cache. Ask the root, we traverse the root servers, right? When we get to company.com, rather than handing back an A record, what they set up for this architecture, delegation mode, was I'm going to tell you to go ask somebody else. I've delegated that to someone else. You do that using what's called a CNAME record. Okay? So rather than handing back an A record, it hands back a CNAME and says, go ask subzone.company.com. He's the one that knows the answer. Okay? Then we'll come in and ask that, traverse the tree again, find out who subzone.company.com is, and when this is a BIG-IP, it's been delegated to a BIG-IP, before we hand out an answer, what might we want to do? Check whether it's available, right? So we're going to go the potential answers to that name. We're going to go do monitors just like LTM does. Actually, there's even more monitors in GTM. Check those devices or check those apps, IP and port, right, is how you do a monitor, and decide that, oh, I can't get to this one, or he's not responding to me the way I think he should. Let's hand out this guy as the answer. So then, once we've done the monitoring, we'll decide what address we're going to actually hand back, and we only hand back one, right? Hand back an A record, and very important, we hand back TTL. By default, the TTL is very short, 30 seconds. You can modify that. Why do you think we're doing so short? That means there's going to be a lot more. It's going to time out up there, and we're going to get a lot more DNS traffic, right?
Because it might not be available. We want to know that.
Either now this guy's not available, or this is really the better answer and it's back available, right? So in order to accommodate that, we have to have the client ask us the question again, right? Who is www.company.com? So we want to send it with a very short TTL. Now, one of the exposures, like I just said, is we send it with a very short TTL, and that's a hosting provider, and they don't abide by 30 seconds, right? They're not going to do that. They're going to make it into 4 hours or something. Oh, well, we can't do anything about that if they override what we're trying to do. Question?
Make more sense if we publish a virtual server on the LTM.
Potentially. This can be a virtual server, but there's no requirement of this being an LTM. There's more things we can do if it's a BIG-IP, but it could just be an individual host, a web application, individual host, right? And there are things we can do with that guy, right? I mean, LTM monitors hosts, what's the IP, what's the port, and looks for like content coming back from that website. We can do that with GTM. or DNS. So, but you're right. We can, if it's an LTM, there's more things we can find out about it than just a normal Apache website.
You don't need to have low TTL values and like that.
Yep. Question?
Regarding the CNAME
Okay.
response, you said it starts all over again, but at the end of the day, you will reach the company.com to resolve that domain.
Correct. Correct. But you're delegating, in this case, this name to subzone.company.com rather than company.com.
Okay, but on the first response, the DNS, the real DNS, also provides the, who is the other DNS?
He will tell you, go traverse the tree, and then he's got to go look that up in company.com, who is subzone.company.com, right? And
Yeah, but I don't understand. What I didn't understand is the local DNS will not start all the process again to the root.
correct.
Okay.
Correct. Yeah, I think my slide was a little bit misleading. It looked like it was going to the
I
root.
think you said that, well, I might be mistaken, but you said that we would go over the process again. I understood
No.
it was to the
Yeah.
root. It might
Yeah.
be
No.
understanding
Sorry.
wrong.
Sorry. Correct. It does not go back to the root because we're drilling down deeper into the zones. Correct. Good? So this was the old way, and the reason it was the way a lot of customers used back in the day was because there was less that we were touching of their DNS infrastructure, and that was good. That was what they wanted. They didn't want us to mess with it, right? But some of the stuff that we're doing with security now with the DNS infrastructure, you need to be in a second mode, a different mode than this. It won't work. The other mode, once they make the connection, the other mode is what you might hear referred to as either authoritative or inline. Inline to me describes it better because that's what we are. We're sitting the BIG-IP DNS device in the path to the back-end bind servers. And there's many things, because we're in the path, just like LTM, many things we can look at and do for those back-end bind servers, maybe to where they don't even have to answer, right? So here's how this would work. Ask the local DNS that you have to have this particular setup or this mode, be running in this mode to do either DNS Express or DNS Sec, some of the security things that we'll talk about here in a second. So ask the local DNS, right? Local DNS then sends the query to where he thinks the bind servers are, right? But we're sitting in the middle, and as that query passes through the BIG-IP GTM or DNS box, we're going to look up and see if that name, that www whatever name, matches configuration settings that we have. The first thing we look for is, it's a listener, we'll talk about that more in just a second, does it match what's called a wide IP? That's our global server load balancing, distribute traffic across data centers. Does it match the name of a wide IP? If it does, then we hand back that answer. If it doesn't match a wide IP, then does it match an entry we have in what's called a DNS Express zone? We'll talk about that more in just a second. And hand that back as an answer. Notice we still haven't asked the back-end bind servers anything yet, right? If it doesn't match one of those two, there's one or two other things we'll do. We'll look for it in our own cache if you have caching turned on. Not on by default, but we'll do a couple other things. But then, if we don't match any of those things in our configuration, then potentially you could have these guys set up where you're load balancing them as a pool to distribute traffic across them. And so we'll go ask the back-end bind servers, get an answer back, and then hand back that answer to the clients. Finally, we might go, if you have bind turned on, look it up, bind on the BIG-IP. Not necessarily a recommendation, but you can. Okay, so this is this order of precedence. We'll have another couple slides on how this actually works. But because we're in line, there's a lot of things we can do. And you saw many of them, we never even bothered these guys, right? We're kind of helping, just like LTM does, as the proxy in between and avoiding like DDoS attacks. You know, we can look for some of that stuff here specific to DNS, the DNS protocol itself, and they never get hit with it. So Authoritative or inline is really the recommended way anymore. As the SEs will go out and talk to customers, this is the way I would push them, because then they're going to be able to take advantage of some of the other features, right? Yeah.
Why can't you just get rid of the DNS server?
You can.
It seems like BIG-IP is
You can.
out, right, already.
So how I usually answer that question is many customers are using this as their DNS server. It's really, really fast because of that full proxy architecture and TMM. You can do a lot of things in RAM, which make it even faster than just the architecture itself. And yet there's some things that we're, I would say, almost purposefully not choosing to go into yet. You can manage the bind configuration on the BIG-IP, but it's not as nicely done as like info blocks, for example. So in many cases, the answer I usually give is you might want to put this in front and yet still use info blocks to manage the back-end bind configuration on those devices. They will say, well, if you're doing that, then why do you need FI? But we tend to avoid, we help avoid a lot of the attacks and stuff that we're good at on LTM, same type thing, as a proxy. Good question. Kind of the same question for Palo Alto, right? There's things that the Palo Alto firewall does very well that we're not quite as good at yet, and yet there's things that it's horrible at, SSL termination, for example. Use them in combination. We're not suggesting that you get rid of that, just you don't need to buy a bigger set of firewalls, put a BIG-IP in there, and then you can do what each product is best at. Good? Yeah.
Do I have to change anything at DNS servers, make a configuration?
For this one, no.
I can use for holdings, which are
Yep.
a group of companies, because I have a customer that cannot control, don't have their own DNS servers, and they have kind of IT company also, which is providing infrastructure, DNS, and some support
Yep.
to them. But they want to buy this solution, but they always ask, we don't have our own DNS servers, so how can we do that? That's why.
Leave this alone, right, and managed wherever. Just make sure that the path, again, the suggested way to do this is authoritative or inline, which authoritative means kind of the same thing as inline. We're authoritative, but only for certain things. If we don't have that particular name configured within the BIG-IP, then at some point we'll pass it to the back-end servers and they'll answer, and we'll hand back their answer, right? So we're authoritative for some, not everything. And yeah, you can just, in that case, what you're asking, they can just leave these guys alone and just put us in the path.
Why is authoritative so common?
It's just a way, it's more of an industry term, meaning that we are going to answer for certain names. We're authoritative for those names. Everything else will pass on.
But can we, if I am going to implement a DNS solution scenario for a company, imagine they say, I want to dismiss my bind set, also master and authoritative. Can I, with BIG-IP DNS, replace
Yes.
infrastructure and handle all the authoritative?
You can essentially, what you're typically doing when you put BIG-IP in and you're replacing their whole structure is it's almost like you're putting BIG-IP in as the LDNS, if you think about it.
So the strategy is more like, let's say I have some apps which have to be accessible from outside, so I'm going to manage those names into BIG-IP, and for whatever which is inside the laptop, or laptops have a DNS, all the internal stuff you keep your
Yep.
info box.
You keep your existing infrastructure. Yep. Whatever that is. What we're trying to do is make it more available, protect against attacks. The same thing we do with the rest of the products, right? Good? Okay, so next section we want to kind of do a little bit of a history. and talk about how we got here. You know, where the product started was all this global server load balancing stuff, but we've added some things along the way that I think are pretty important, and the main reason why we changed the name from GTM to DNS is because we do a lot more with the DNS infrastructure or protocol itself to try and help protect it. It's the second most attacked behind HTTP and HTTPS, right? So we want to talk about a few of those things. Specifically, I'll look at DNS Express and try and describe to you how DNS Express works, because it's a very powerful feature in this product. And then we'll come back and talk about this order of precedence. DNS query comes in for a certain name. There's an order that we kind of look through our configuration to decide which match, if it matches at all, which match will then decide what address record we're going to hand back. Or we do MX records now. We do other records than just A records. Okay, so we'll talk about that. And then we'll go do a lab at the end of this lesson. So we're not going to get into the main reason the product has been around forever, the global server load balancing, until the end, because I think it kind of makes sense to cover that order of precedence and have you see it in the lab. Then once you got that kind of cemented in your head a little bit more, I think it'll be easier to then get into this and have this discussion in a couple parts. This is that part that you got to go understand about this before you can understand about that, but you have to understand about that before you understand this. So we got to kind of build it up a little bit at a time. Okay, so the history of the product, we've always had that global server load balancing. In fact, this product way back when was named 3DNS. It was an F5 built product. When we, if you remember the discussion we had a few days ago, last week I guess, the history when we came to BIG-IP, version 9, and we did the full proxy, we decided there was a lot more brand recognition of BIG-IP than F5. So when we got to BIG-IP version 9, we decided this product would work very well on that proxy architecture. Let's bring it over also, and we renamed it to BIG-IP GTM. Now it's been renamed back to BIG-IP DNS, not 3DNS, but there's been a lot of other features added in the last V10, V11 versions. Most of them have to do with security for the DNS protocol. A few are just other things that customers have asked us about, like IPv6. You can ask for a name, and if it's an IPv6 client, we can hand back a quad A record versus a normal IPv4 client, just an A record, right? So we can decide whether we're going to hand back IPv6 or v4. We also have added a fair amount of caching features on the product, but those are disabled by default. We'll talk about that in the order of precedence discussion. They're disabled by default because if you turn that on, you're kind of now exposing BIG-IP to the same DOS attack type of mentality for the DNS protocol. So by default, we want to leave that off. If you decide to turn it on, that's okay. Just be aware that now we're a little bit exposed also for some of the typical attacks. So historically, I'm not going to go as far back as the 3DNS product in V3, V4 days. V9 is when that product came over to the BIG-IP code trunk and became BIG-IP GTM. We'll just start from V10 and go forward. So in V10, we did add IPv6 support. We added DNSSEC, or the start of our DNSSEC answers to that feature, but we finished out more stuff on DNSSEC and definitely did more on IPv6 with the first versions of 11. Version 11 was where we added this feature called DNS Express. The big, this is going back a few days. I know that you guys are probably fading since this is the last day, but if you remember, one of the things we said that we wanted to do for performance reasons was do multiprocessing in a different way than the industry, right? CMP. And that's implemented in TMM. We have an instance of TMM, the traffic management microkernel, on each of the cores or each of the CPUs, and we can scale very well because we just distribute the traffic across those. One of the things that happened was when we did this DNS Express feature, we took some of the code out of what's called the GTM daemon, GTMD, and we moved it into TMM. And so all of a sudden, moving from V10 to V11, you could get, on the exact same hardware, you could get this much more performance with that part of the product, which was a huge part of the product at that point, just by moving to the V11 code trunk, right? You took at least your GTM product set and gained huge amounts of performance just because we were more efficiently using the multiprocessors on whatever chassis you were on. Okay? GTMD didn't do it exactly the same way, where TMM, now having owned parts of answering that query, we just got a lot more efficient. So DNS Express was a big deal with 11.0, huge on performance. With 11.1, 11.2 is where we kind of started adding some of the caching features. I'm not going to go over each one of these, but 11.1, 11.2, we added some of the caching stuff, did more on DNSSEC. 11.3 was kind of the visibility and reporting or analytics release for BIG-IP DNS, so there was a lot of stuff added there. And then the biggest thing on 11.5, I'm not going to really talk about 12 or 13, biggest thing on 11.5 that changed was we put everything into one menu. We'll show a screenshot of this that you guys at some point will have older customers, like either V10 or V11 customers, 11.0 customers, that if you have those guys, you'll have to know that when I go into their configuration for BIG-IP DNS, that there might be parts of the config I go into local traffic, like load balancing the bind servers, and other parts where I go into the DNS menu, or at that point it was called global traffic. Biggest change that happened with 11.5 was all that got condensed into the DNS menu. Big improvement, right? Even if you're load balancing back in bind servers, you can go see them on local traffic under virtual server and pools, but you can at least go in through the DNS menu and configure them, right? Under the covers, what's happening is it's going over and doing that for you as part of LTM. But you can see them through the DNS menu, and we'll show you a visual of that. Yeah?
Regarding I'm not sure if that's what I'm going to touch, the change of the name, it seems we're going to tell the market, okay, now we are DNS, because that's an offer we're working on Brazil to replace. We're doing load balance among the DNS,
right? And
now the offer is, okay, get rid of all of this and it'll become a DNS.
So how I pitch it is, when we came out with version 12, the biggest change that we did was we changed the name. There was features that we added, but small features. We changed the name. So how I answer that is we wanted to call out that this product does a lot more with the DNS infrastructure or protocol specifically than just global server load balancing. And the name previously, Global Traffic Manager, was to denote that we distributed traffic across data centers, right? That's really what the product focused on. Now we have a lot more in there than just that. So we were trying, by the name change, to call out these other things that we do. I would say there's still certain pieces that we're not trying to tackle, like being the bind servers, because a lot of people are using info blocks and they're a little bit better GUI than what we have.
Yeah.
We outperform them.
Yeah, because that's the point.
Yeah.
As Roman said,
I think
we're handling all the transactions
Yep.
anyway.
Yep. We outperform them, but from a bind management, like a GUI bind man, what's one of the biggest issues that people typically have with bind or DNS? Attacks, but many of the issues they have when their DNS goes down often are their own fault, because if they're hand editing bind files, then And so they do utilize the GUIs in many cases so that they avoid those problems, right? And our GUI is okay, but a lot of people like InfoBox better.
I think this change of name is better because if you want to try to set a DNS like an internet service provider or a company, I have the feeling that to configure the DNS, I have to use GTM. It's like the DNS is a commodity. If you rename the product DNS, it's like you are proposing to your customer, oh, we have a DNS.
Yeah, that's what I'm saying, because
Yeah,
now we're
exactly.
pitching
Yeah.
that we have a DNS.
Yep. 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 The bigger issue you probably will have is when you talk about the product, you have to change your vocabulary as SEs, right? You have to say DNS, well, you're talking about the protocol or are you talking about the product? So you almost have to put into your vocabulary when we use BIG-IP DNS versus, anyway, that'll probably be as much of a problem as anything when you guys are talking about this guy. Sir?
Do you know if F5, like in versions your team, maybe they're going to try to improve this GUI, this UI for the
I'm not aware of that. Don't know. Don't know. Good question.
Let's see where we go.
So I'm not sure. Good? Okay, so let's keep going. DNS is the second most attacked protocol. This is a little bit of a dated slide because it's got HTTPS listed over here. I think you consider HTTP and HTTPS together now, and they're by far the most attacked protocol, but DNS is just behind that. You bring DNS down, a customer's DNS, nobody's going there, right? So big deal. And this is some of the stuff that we're trying to help with this product. Specifically, I'm gonna talk about one or two of these types of attacks and zone in on DNS Express and talk about how it could help from a DOS perspective. So DNS Express, how it works is you have your normal bind servers and they have all the zones configured over there and managed over there. What we're going to do with DNS Express is we're going to do the exactly equivalent of a zone transfer, and we're going to suck in a particular zone and we're going to actually put it in RAM on the BIG-IP. So we'll have this whole zone that we suck in for maybe an example might be internal.company.com. Right? We might suck the whole internal zone over. Not everything these guys are managing, just certain zones. Actually, the better example to pick on would be external.company.com, right? Because we want to help with their external site to their customers and make sure that's always available. So we suck in the whole external.company.com zone, and then we'll answer for that zone. Now we continue. It's basically kind of like we're caching it, but we're not really. It's a zone transfer, which means then that we continue to monitor or check with this guy, have you changed anything within that zone, and we'll get updates, right? Just as a zone transfer works, we'll get updates whenever they change things on the back end. So zone transfer, but also in RAM, which makes it faster, but really the thing that makes it so fast is the multiprocessing, right? We can get hammered and stay up and not have these guys get hit at all and alleviate that DOS attack in that manner, just because we respond so fast, right, with the architecture. So we handle up to tens of millions of records. We can do 200 times a traditional bind server, speed-wise from a performance angle. Bind and DNS has really not been designed for today's security attacks. It's an older architecture. They've added some things like DNSSEC to try and help with that, but it was designed a long time ago, worked very well, and yet some of the attacks these days, it's kind of exposed just because of how it works, right? So this is our way of trying to avoid some of that. Kind of worth noting the differences here. You might think, well, that sounds kind of like caching, but there's some significant differences between DNS Express and caching, right? DNS Express really is more like a high-speed slave server. It only has a certain zone, and it's only going to answer for that zone stuff. Caching, there's good and bad, right? Caching is good because it saves internal resources from looking things up multiple times, but it's also more exposed to some of the typical DNS DOS attacks, where DNS Express is not. We're going to answer really, really fast, be done, right? Some of those reflection attacks and things that they'll go try and get a DNS server to go look up for them, that's how they compromise them. We're not authoritative for that, so we don't answer, right? And what you want to do is you want to give your legitimate clients answers to who is www.company.com, right? You want them to get a legit answer. The hackers will too, but we'll at least continue serving the legitimate clients. Okay? Kind of make sense? Not a cache. Different perspective. More like a high-speed slave server. So let's kind of go into this discussion about order of precedence, and then it'll lead us right into a lab, and the lab will reinforce this idea of order of precedence and kind of give you an idea about how we're going to treat each of these DNS queries coming in, which answer we're going to hand back, because we might match multiple of the pieces of the configuration. So at a high level, just if you remember the discussion, you plug BIG-IP in the network. It's a default deny device, right? In order to start processing traffic, we've got to do a listener. You go actually set up in the DNS GUI a DNS listener. That's what they call it. There's times where I wish LTM would have grabbed that before DNS did, but we already had it named as a virtual server. Kind of hard to change the name after a while. Everybody knew it as a virtual server. So under the covers, that's exactly what this is. Guess what port it's configured on? 53, right? So it's a virtual server at port 53. So you go configure the listener. The first thing we're going to go look to see if this DNS query matches is, do we have a wide IP? That global server load balancing intelligent resolution. If we do, that matches this name, then we're going to hand that out as the answer. Next thing is, do we have an entry in a DNS Express zone? If we match that, no wide IP that matches. Do we have an entry in a DNS Express zone? Yes, hand that out. Then we start looking at some of the caching entries we might have. Doesn't match that. Do we have a pool of bind servers that we can load balance to, or even just one? Right? Is that part of the configuration? We'll hand off to them, hand that out as the answer. Are we supposed to go in caching, look it up? Did you turn that on? And then finally, if you have local bind on the BIG-IP, we'll go look it up in our bind tables. Not always recommended, because you're using us in a different way. You know, again, you guys are asking questions. Is this what I should be doing? Some customers do, but some customers use it as a front end to their bind servers. So, kind of depends. Let's go through question.
Can you just explain what's a wide IP?
The wide IP is the intelligence behind sending things to different data centers. So it's the piece, for instance, www.f5.com. We might have potentially data centers in North America that could answer that request. Excuse me. Data centers or a virtual server in APAC that might answer that, and data centers in EMEA that would answer that. And maybe you want your clients to go to the closest one, right? That would be a wide IP configuration that would say, for www.f5.com, I'm going to use this type of load balancing. I'm going to monitor those particular IPs and make sure they're up. And then based off when they come in, I'm going to hand out the best answer for this client, maybe different best answer for this client. Well, we'll have all sorts of other configuration, load balancing and pools and monitors that we go configure, yes. That's the intelligent answer that we want to hand out.
But I mean, that is like local bind, right?
What's that?
at the end, it's like a local bind, if you think. Because
If you have it turned on.
No. Even the wide IP, you're sending the destination of the server, or you're redirecting to another DNS?
Correct. You're sending so the wide IP is an A record.
Okay.
Or an MX record.
It would be like a local bind for that response.
Yep.
But with DNS Express, can I configure also a record and authoritative zone without
For DNS Express, we're not configuring anything other than we're doing a zone transfer from some other bind server. So we don't configure anything other than actually doing the zone transfer, and who are we doing the zone transfer from. So DNS Express, you're not adding this A record, adding this MX record, you're just doing a zone transfer, and whatever we pick up from that guy on that zone is what we get. Wide IP, we're specifying a name, www.f5.com. And we're only going to hand out intelligent answers for that name. Right? FTP.f5.com, we may not have a wide IP for because we aren't as worried about that. Maybe it wasn't in the DNS Express zone, so we might be handing that off to our backend bind servers and letting them answer that question. Right? So order precedence. So when you get into lab, there's a few screens you're going to go through. Let's walk through those screens in terms of this picture here. So first, we go configure the listener, and you go into the DNS GUI. That local traffic, network, and then DNS would be on the left-hand side here, right? Go into the DNS GUI, and we're going to go configure the actual listener, right? Also down below, as part of the listener configuration, and this would show up if you go to local traffic. If you have LTM provisioned, you don't have to have LTM provisioned, right? It can just be DNS or GTM. So if you have LTM provisioned, then you could go over to local traffic, virtual servers, and you would see this show up there as a port 53 virtual server, right?
You can have only DNS.
Yeah, you can have only DNS. Yep. Provisioned if you want. Yep. So that would show up there, right? This listener would show up there. Also, we said there's a lower order of precedence would be the DNS pool. That's configured as part of the listener, the load balancing or default pool, right? And then we've talked about different config objects for a while now. All these other settings are going to be part of what would you guess if you were to take a guess. We have a virtual, we have a pool. What other configuration objects have we talked about that we've used on many virtuals? Profile, right? In this case, it's a DNS profile. Surprise, surprise, right? And in that DNS profile are all of these configuration settings, the DNS Express. So let's go look at that. In the DNS profile, and one thing that's nice is you'll notice they're all in order. These are the default settings on this, shown on this screen, right? And they're all in order, right? So at the top, are we going to do intelligent load balancing or not? Global server load balancing. It's enabled, right? It's on by default. Next, are we going to do DNS Express? Yes, enabled by default, right? So it's the order of precedence is followed actually in the profile. Didn't used to be that way in older versions 11, but they finally somebody I think asked, so if that's the order of precedence, why don't you just put them in that order in the profile? Oh, that makes sense. Okay, we'll do that. So we did. Notice, remember we talked about caching, and I said that kind of exposes us to some of the attacks. So by default, caching is not enabled. You would have to go turn it on. Okay? And then down DNS pool, if you remember, is configured on the listener. And then finally at the bottom, bind. Now bind is enabled by default, and I haven't actually found the right person to ask the question of, but my guess is it's because of a historical perspective that it's always in previous versions, it's been turned on. Customers haven't always used it, but it's been turned on at least. And so we don't want to change a setting across versions. So it's still enabled by default, but many customers right now are not running bind on the BIG-IP because they want it to be that front end. They want it to be in between the clients asking the question and their back-end bind servers. They want that proxy capability, for their DNS infrastructure. Good? Kind of make sense? Okay, so last thing we need to talk about, two more things. I told you the GUI's changed, right? In 11.5, everything is under the DNS menu. Previous versions, you might have to go over to local traffic for some of the pieces, like pool of bind servers. You would go, here would be a virtual, and then you'd have a pool, right? But also DNS Express zone transfers were set up over in local traffic. If you have customers with older versions, you might have to go to a different part of the GUI to help them configure it. Last thing before we do lab is when you're doing this, we're going to test. We're going to set up configurations and we're going to go test it. We're going to actually issue queries to the BIG-IP, and we want to see these things work. You can't do that from BIG-IP itself. So you need to have a chunk of code on your client machine to go actually test this and make sure it's working. First, you can issue the DNS xdump command to go look at what came over in the zone transfer. Okay? But to resolve the names, we're going to use a couple different utilities, or your choices are a couple utilities, maybe I should say. Windows has NSLookup installed by default, but not DIG. I would highly recommend if you're running on a Windows client, you go install DIG. Okay? Much better tool for messing with this. One of the things that NSLookup does is it will, if it gets an answer back, it'll cache it. So if you're using NSLookup and you do another NSLookup and you think it should be changing, it may be NSLookup that's messing you up. I think to get rid of that behavior, you have to do an if config /flush DNS, I think is what you do, is the command. But personally, I just go install DIG on your Windows machine. Macs, you've got it already. That's what you use. Okay?
Oh, I have DIG. I always use
Yep,
the
got
NetScout.
DIG. Got DIG on a Mac. So it's a Unix machine. So you then use the listener as the IP address you're going to dig and ask the question of, right? And then you'll see it move around. And like I said, in this lab, what we're going to kind of do is we're going to go set BIG-IP up, BIG-IP A up, and set up a particular configuration, and we're going to kind of test this order of precedence, right? So we're going to go configure a pool first. You're going to issue the dig command, and you should see statistics going to the back-end pool members, right? Because that's all we have set up. Then we're going to go do a DNS Express zone transfer. Now you should see it be answered by there and no stats to the back-end pool members, no traffic to the back-end pool members, right? And then finally, we're going to do a dummy wide IP with an iRule, and then you should see that answer come from here, right, from the wide IP. And then we'll kind of back that out in lab. Any questions before we get to lab? Okay, so lab is and we can do a break now too. Lab is the 7.1 lab in your book.